Okay, so today's lesson we're doing section 5, which is law of cosines. Just a refresher what we've already learned this chapter for triangles. We've learned right triangle trig. What do you use for right triangles? SOHCAHTOA. And we learned right before school got out, we learned about the law of sines. And in the law of sines, that can be used on any triangle, but you have to have enough information in that triangle so that you can complete one of the ratios for law of sines. For example, if you are given two sides, you have to be given the angle opposite one of those sides. Or you can be given two angles and any side at that point, because if you're given two angles, then you can go ahead and get the third angle, and so you'll have a complete ratio. But for law of sines to work, you have to know an angle across from a side in completion so that you can do your ratios. So what do we do when we have a triangle that's, let's say, three sides, and we don't have any angles? Law of sines won't work, and that's what today's law of cosines, is going to help us with some other triangles where law of sines doesn't work. So law of cosines, basically, and I do have a printer error on here, so on your printed notes, I may have fixed it before I put the printed notes on SaintsNet. I can't remember now, but if not, you can fix it right now. That should say an a squared right here. These are all three the same formula. So you really only have to memorize the format of the formula, and then the letters just move around. And what determines whether an A goes here, a B goes here, or a C goes here is which angle you're working with. So if I'm working with angle A, then it means that the entire formula will equal side A squared. So side A squared goes here if I'm working with angle A. And then the rest of the equation will be the other side. So B squared plus C squared minus 2BC cosine of angle A. And that 2 is pretty much one of the biggest mistakes people make, is they forget the 2. So don't forget the 2. You will need to have this formula memorized for the test and the quizzes. Well, we won't have a quiz on this, so on the test. Let's say instead of angle A, we're working with angle B. Well, if we're working with angle B, then the side opposite is little b. So little b goes here, so b squared equals a squared plus c squared minus 2ac cosine angle B. And then same thing, if we've got angle C, then the side opposite is little c, so the whole formula will equal little c squared. The other two sides go here, a squared and b squared, minus 2 times the other two sides, ab, cosine of angle C. So the angle you're working with determines the side over here, and then that determines the sides here and here. And make sure you fix that mistake on the printed notes if it's missing the a there. That's a squared. So we're going to do our first example. The first example says to solve triangle ABC, given the information we're given. And again, if it says solve a triangle, that means what? Find all the parts, all the missing parts. So let's draw ourselves a triangle. Triangle ABC. Angle C is 57 degrees. I don't know if you can see the purple, so I'm going to switch to black. So angle C is 57 degrees. Little a is 18. Little b is 24. And we want to find all the missing parts. Well, can't use SOHCAHTOA, it's not a right triangle. Can't use law of sines because I don't have a complete ratio. So I have to use law of cosines. So since the angle that I know is angle C, then the whole equation is going to equal the side across from it, which is little c. So little c squared equals the other side, so little a squared, so 18 squared plus little b squared, 24 squared minus, don't forget the 2, times the 18 times the 24 cosine of the angle that we're working with, which is 57 degrees. At this point, you would put everything on that right side in your calculator. As long as you're in degree mode, you can enter this entire side on your calculator in this step. So you can put 18 squared plus 24 squared minus 2 times 18 times 24 times cosine 57, as long as you're in degree mode, it should come out to be 429.4 according to the book. So we end up with c squared equals 429.4. And they rounded to the 10th. I personally would recommend that you round more like 3 or 4 decimal places. You'll get the most accurate answer. But we'll use the answer that the book gave in case you're following along with your book. And so at this point, we need to solve for c. How do we do that? We take the square root of both sides. And normally when we take the square root, how many answers do we get? Positive and negative. But since we're talking about the length of a triangle, it can only be positive. So the square root of 429.4 comes out to be approximately 20.7. So now we have side C. So now they want us to find angle A and angle B. How can I find angle A and angle B now that I know that side C is 20.7? That's right, we can use law of sines now because we have a complete ratio. So we can do sine of angle C, so 57 degrees is to 20.7, as, does it matter which angle I get next? Does not matter. So it's your choice. I'm going to go with angle A, so sine of angle A is to side A, 18. From this point, we would cross multiply, so 20.7 sine A equals 18 sine 57. Divide, we get sine A equals 18 sine 57 degrees divided by 20.7. When the angle's unknown, how do you put in your calculator? That's right, you have to use the inverse feature on your calculator, so sine inverse of this whole number, and that's going to give me the angle A that I'm looking for. And so when you put that entire thing in your calculator, the book did round a little. They rounded it actually to a whole angle, and they said angle A comes out to be 47 degrees. So now that we have angle A, all we have left is angle B. How do we get angle B? That's right, we know all 3 angles add up to make 180. So 47 and 57 make 104. So what's left over for angle B? 76 degrees is correct. So our last angle is 76 degrees. So we've solved that triangle. So let's move on to the next example. The next example, triangle ABC, gives us the 3 sides. So this time, instead of knowing an angle and 2 sides, we know 3 sides. So let me draw my triangle. So triangle ABC. I know little a is 15. I know little b is 9. I know little c is 7. Clearly, I did not draw this to scale because which side should be the longest? Side A. 15 should be longer than the 7 and 9. So this is not drawn to scale. 15 should definitely be the longest side, which means angle A should end up being the largest angle. So can we use law of sines? Nope, don't have a complete ratio. Don't have an angle that I can set in a ratio format. So I need to use this new law of cosines. I know all 3 sides, but I don't know any of the angles. So which angle do I work with? It doesn't matter. Pick any angle you want. I'm going to use angle A to look for. So if I'm using angle A, so this is the angle I'm using, that means the whole formula is going to equal side A. So we're going to set the entire formula equal to side A, so 15 squared equals the other side, so 7 squared plus 9 squared. Doesn't really matter the order. If you did 9 squared plus 7 squared, addition is commutative, so the order doesn't matter. So minus, don't forget your 2, times 7 times 9, cosine of the angle that's across from 15, which is what we don't know. So angle A. Now what's different about this example from the one we just did? We don't know the angle this time. So when you don't know the angle, it's a little bit different how we have to simplify it. We can't put this entire side in your calculator. Cannot do that like we did on the last one. We have to actually simplify this in pieces. So first thing we have to do is find what is 15 squared. 15 squared is 225. Then we have to find what 7 squared plus 9 squared is. So 7 squared is 49, 9 squared is 81. We're going to add the 49 and we're going to add the 81. So someone tell me what 49 plus 81 is. You should get 130 minus, we're going to go ahead and multiply this together. So 2 times 7 times 9. So 2 times 7 times 9, well 9 times 7 is 63. And then you multiply that by 2, so 126. And then this is where I want everybody to pay close attention. Are you allowed to subtract 130 minus 126 and make it 4 cosine A? You are not. That's the biggest mistake students make here is they go ahead and make this 4. Why can't I do that? Well, this would be the same if I did, what's 5 minus 3x? Can we make that 2x? No, we cannot. This is married to the x. This is a 5 by itself. 5 minus 3x does not make 2x. 5x minus 3x makes 2x, but that's not what we have. So we can't add these because these are not like terms. So instead, we need to isolate the cosine A. So how would I isolate the cosine A? First thing I would do is move the 130. So 225 minus 130. So that gives me, I'm doing all this math in my head, is that 95? So that gives me 95 equals negative 126 cosine A. Then what would I do to isolate the cosine? I would divide by the negative 126. And so we end up with negative 95 over 126 equals cosine A. And the angle is unknown. How do we put it in our calculator when the angle is unknown? We use cosine inverse. So we have to use the cosine inverse button of negative 95 over 126, and that will produce angle A. And according to the book, angle A should come out to be 139 degrees. So make sure you're practicing putting this on your calculator to make sure you get the same answer. So angle A is 139 degrees. Now that we have angle A, how can we find angle C? Let's say we want angle C next, or maybe we'll do what the book did. The book did B next. How would we find angle B? That's right, we would use law of sines. So because we have a complete ratio, so sine, we need to find some better markers. So sine of 139 is to 15 as sine, what did I say we were going to find? Angle C. So sine of angle C is 7. It doesn't really matter if you'd rather find, no, I was going to find C, but the book's finding B. So we'll do what the book did. So angle B is to 9. So you would cross multiply 15 sine B equals 9 sine 139. Divide by 15, so sine B equals 9 sine 139 over 15. And then how do you put that in your calculator? You use the inverse button. So sine inverse of all of this. Make sure you're in degree mode for all of these triangle problems. And angle B comes out to be 23 degrees according to the book. So we now have angle A is 139, angle B is 23. What do we know all three angles make? 180. So what's left over for angle C? That's right, it is 18 degrees. So we found all three angles when all we were given were three sides, but we had to start with law of cosines. The good thing about law of cosines, remember the ambiguous case for law of sines? Don't have to worry about that for cosine. The cosine formula is never ambiguous, so that is not something you have to worry about. So then we have to look at how do we decide which method to use for an oblique triangle? How do we decide, do I use law of sines, do I use law of cosines? Well, on page 795 in your book, there's a nice little chart right here in the middle that tells you how to decide. It says if we have two angles and any side. So if I'm given two angles and any of the three sides, doesn't matter which one, I can use law of sines. If I have two sides and an angle opposite one side, so I'm given two sides and I have an angle across from one of those sides, I can use law of sines. Law of cosines I use when I know two sides and an angle between them, like the first example we did in this lesson. And I can use law of cosines when I know three sides. So let's look at the word problem example that's in your book. You do need to look in your book. I hope you've had your book with you. You should have your book with you during all of these recorded lessons. So let's look and see what example 3 says. So example 3 says a medical rescue helicopter has flown from its home base at point C to pick up an accident victim at point A. So here's the helicopter's home base. Ooh, there's my helicopter. Aren't I a great artist? And he flies to the accident victim at point A. So here's my car that's had an accident. Okay, so here's point A, here's point C. And then he flies from there to the hospital at point B. So here's my hospital at point B. And then it says the pilot needs to know how far he is now from home base so he can decide if he needs more gas before he returns to home base. So if he's flying back to home base, he's not going to go this route. He's going to fly directly, right? You've ever heard the saying, the way the crow flies, he's going to go the most direct route. So that's what we want to figure out, how long a distance this is. So they told me in the picture that from home base to the accident is 50 miles. From the accident to the hospital is 45 miles. And they told me that the angle formed between this line of flight and this line of flight in the picture is 130 degrees. We want to find this distance. Which of my laws can I use if I know two sides and the included angle? I can use law of cosines. Law of sines won't work. So since this is the angle I know, what is my entire formula going to equal? That's right, the side across from it. So x squared equals one side squared plus the other side squared minus, don't forget the 2 times each of those sides, times cosine of the angle that's between them, 130 degrees. Since we know the angle, this is one of those where we can put the entire problem in your calculator. This is the easier one when we know the angle. So we get x squared equals, and I'm going to look in my book to save time, x squared comes out to be about 7,417.5. I do want you to check that on your calculator because if you're not getting these answers, we need to figure out why or you'll have trouble on your homework. And then your last step, square root of both sides. We're talking about distance, so the answer will only be positive, and that comes out to be 86.1. What were my units? That's right, 86.1 miles. So the helicopter has to fly 86.1 miles from the hospital back to home. Look in your book as well on Check Your Understanding. It's at the top of page 796. So I'm going to erase this. Everybody have it? Okay, so let's look at Check Your Understanding. For the first two examples, we're not going to solve them. I just want you to look and tell me which law you would use first to start solving it. So the first one, at the top of Check Your Understandings, the top of page 796, look at number 1. It says, determine if you would begin with law of sines or law of cosine. So for number 1, this is what they give us. And this side is 10.5, this side is 11, and this is 35 degrees. And I want to solve the triangle, which would mean find any missing parts. But what law would I begin with? For number 1, if I know 2 sides and the angle between them. That's right, we would use law of cosines. And what would be the first thing that we would find? That's right, we would find side C first. And then after we find side C, we could look for other things. We can't use law of sines because there's not a complete ratio. You have to have a complete ratio to use law of sines. So let's look at example 2. So on this triangle, ABC, we have 40 degrees, 14, and 70 degrees. I think that's what we have. Okay, so what would we use to solve this triangle? Law of sines or law of cosines? That's right, this time we can use law of sines. How come we're ready and we're able to use law of sines for this one? That's right, because we have a complete ratio. We know sine of 70 is to 14. So what does that mean the first thing is we would find? We would find side A first, because we could do this ratio and set it equal to that unknown ratio. Good. Any questions? If you have questions, send me an email and we can, during office hours, on the day that this lesson is being taught, I can go over, questions if you have some, after you have a chance to get started on the homework some. So I'd like you to get started on the homework and then send me an email and I can set up, if I can either respond by email or set up a Google Meet to talk to you during the office hours on the day that 13.5 is being taught. Okie doke. Bye.